We're now going to have a look at factorization that contains mixed examples of all the different things that we've been going through from episode 1 to episode 7. And this is where people start to have a little bit of difficulty, because when they look at an example, they first of all have to decide which type of factorization it represents. And the best advice I can give to you in that respect is that you need to analyze very carefully according to the guidelines that I've been giving you in the other episodes. So if we look at this first one, we've got two terms and we've got a minus sign. So immediately it's starting to look like either a difference of two squares, dots, or a difference of two cubes. So we see a cube there and we see a square there, so that's already causing a little bit of confusion with what's going on. If we look at our numbers, that's definitely not a perfect square or a perfect cube. That is a perfect cube, but then we've got a square there. So there's just a lot going on that isn't quite making sense. If that happens, then what you need to do is you need to see, first of all, if there's a common factor that you could take out of these two terms so that they could become either a difference of two squares or a difference of two cubes. So let's look at the variables first of all. Here we've got an m cubed and there we've got an m. So straight away we've got a common factor with the m's. There's only an n value there, not there, so there's no n involved in a common factor. And then we've got 50 and we've got 8. What is the common factor of those two? Well, they're both even numbers, so we could take out a 2. 50 divided by 2 gives me 25, which is a perfect square, and 8 divided by 2 gives me 4, which is also a perfect square. So just in taking a little bit of time to do that analysis, I've already realized I'm going to be dealing with the difference of two squares, but I can't do that until I've taken out the common factor. So as we said with the numbers, the common factor is going to be 2. And then what else is common to this term and this term? That has m to the power of 1, that has m cubed, so I can take out the lowest exponent of m, so m to the power of 1. Now I need to see what I'm left with in the bracket. 50 divided by 2 is 25. M cubed divided by m is m squared, minus 8 divided by 2 is 4. I've taken out the m, so I'm just left with n squared. And as you can see now, the contents of the brackets are definitely a difference of two squares. So I can't throw this 2m away. It has to remain there as a factor that I've taken out. And now remember, a difference of two squares is going to factorize into two brackets which look exactly the same except for one having a plus and one having a minus. So the square root of my first term is 5m. I'm going to put that into the front of each bracket. The square root of my second term is 2n, and then one gets plus and one gets minus. So once you've got through that first step, which I call the analysis step, you can proceed quite easily if you have understood all the other methods of factorization. So let's have a look at this one. 24x to the power of 6 plus 3000 y cubed. Right, so I've got x to the power of 6. Remember, that could be a perfect square or a perfect cube because that 6 is divisible by 2 or by 3. 3y cubed, that is only a perfect cube because it's not divisible by 2, so it can't be a perfect square. So already things are looking a little bit like a sum of two cubes because we don't get a sum of two squares. So it's really looking like the cubes. But 24 is not a perfect cube and neither is 3000. So that's where our problem is lying. So what could we take out from both of those numbers that is pretty obvious? I think you'll all spot that that would be 3. So 3 goes into 24, 8 times. I'll still have the x to the power of 6. Plus 3 into 3000 goes 1000 times. And I still have the y cubed. So once again, I've taken something that's been a little bit messy, taken out a common factor, and then created in my bracket a sum of 2 cubes, just like there I created a difference of 2 squares. So that 3 needs to remain there. And then remember, for a difference of 2, for a sum of 2 cubes or a difference of 2 cubes, whatever that sign is, that's what's going to be in your binomial bracket. So first of all, what is the cube root of that? 8, cube root of 8 is 2. Cube root of 6 means I'm going to say 6 divided by 3, which is going to leave me with x squared. Bring down that sign. The cube root of 1,000 means what times itself will give me 1,000. And that should obviously be 10. And the cube root of y cubed, the cube root and the cubed cancel each other out as inverse operations, and I'm left with y. I still need to find my trinomial bracket. So there I'm going to take my first term and square it. 2 squared is 4. X squared squared is x to the power of 4. Whatever that sign was, I'm going to have the opposite sign for my middle term. And to find the middle term, I'm going to multiply this term by that term. So 2 times 10 is 20, x squared y. And my last term is always going to be positive because I'm squaring this term, and when we square it becomes positive. 10 squared is 100, and y squared is y squared. And there it was fairly simple once I had taken out my common factor. So now let's look at something much more interesting that's going to involve quite a lot of analysis step by step as we go down. So this is what we're going to start with. Plus 7 brackets. Okay, so that looks really messy. And that's why I say take a little bit of time at the beginning to try and analyze what's going on. So if we look here, first of all, we have 3 separate terms, okay? And if we look at each of those terms, the thing that should jump out at you is that each of them contains a bracket. So the possibility is that we're doing that method where you take out a common bracket. Then if we look at the brackets, they look almost the same, except this one is p minus 2 and the other two are the other way around. But remember, we have a trick, multiplying by -1 to sort that problem out. Some of you might think, because 2 of them are 2 minus p, let me just change that one. But if you change that one, you're going to get a negative value for your p squared. And if you look very carefully with what will be left over, we're going to have a p squared, we're going to have a 7p, and we're going to have a 10, which makes up a trinomial, doesn't it? So I don't want a negative at the front of my trinomial, because then I'm going to have to multiply through by -1 again to get rid of that negative. So I'm going to rather change these two. And if you remember the method, the one that you don't want to change, you just write down exactly as it is. And then I did explain in a previous episode how to sort this out. Remember that we change the sign outside. Now, I'm also going to do something else here. This bracket is being multiplied by 7, and then on the other side of the bracket we've got a p. So in fact, this is saying 7 times the bracket times p. I don't want the 7 and this p separated. It's just there to actually confuse you. So I'm going to put the p next to the 7. A p right next to the 7 does mean 7 times p. And then because I changed that sign, I'm able to change the order inside the bracket. Here again, it's not the same order as that, so I'm going to change the sign outside, and I'm going to change the order inside. If you can't remember why we actually do that, go back to the episode on taking out a common bracket, and you will see exactly what the mathematics behind that is. So now I have 3 terms, all with the same bracket, which means I can take out that common bracket, And then what am I left over with from each term? From this one, I'm left with p squared. This one I can see easily now because I brought the p and the 7 together. I've got minus 7p, and then I've got plus 10. And some people might stop there. And that's why I'm saying with these types of examples, every time you get to a new step, reanalyze. So look at that. It's a simple binomial. Nothing can be done to it. It can't be factorized further. What have we got in the second bracket? We've got 1, 2, 3 terms, so it's a trinomial. Now look at the trinomial, p squared, p, and a constant. It's going in descending powers of p. So it's looking very much like a trinomial that we would be able to factorize. So let's quickly see if we can or not. We need to find factors of 10 that can give us 7. And because that's a plus sign, we're going to be needing to add the factors of 10. So the obvious factors that jump to mind are 5 times 2. Can 5 and 2 give me 7? Yes, they can. So that is factorizable. So I'm going to write down my binomial as it is. Remember, when this factorizes, it's going to factorize into 2 brackets. So p squared is going to break up into p and p, because p times p gives me p squared. The factors of 10 that I had decided to use were 5 and 2. And then going back to those rules from a previous episode, if this sign is positive, it tells me that the signs in the brackets are going to be the same. And what are they both going to be? They're both going to be negative. And now if you look at each of your binomials that you left within each of the brackets, you cannot go further, and so that is your final answer. There are so many different examples using mixed factorization where you have to first of all do the one type and then carry on with another type. If you would like to see more of these mixed examples, let me know in the comments, and then I can put up another video with another variety of examples. I hope this has been helpful to you.